Like I mentioned previously, this year we've seen this enormous breakthrough with coding agents. So they've really achieved massive economic appeal. You can build a whole super profitable tech company around this idea of serving coding agents. But everybody sort of feels in their bones that this is not the end. Right? So something, what's the next big thing that will come? So one advantage that you have in the coding domain is that you have verifiable rewards. So the agent writes code, and then we have a unit test or some other verifiable way to ensure that what the agent did was correct, and then we can give a reward signal, and then you can leverage all the tools from reinforcement learning to basically improve that agent, make it extremely powerful, and that's what has led to the success today. And I think everybody agreed that coding is one of these fundamental building blocks that you want to solve before moving on to other domains. So no, that's an easy one, but what comes after that? So, and actually I see multiple directions now, some of which you've heard today. So I think this idea of scientific discovery, of the agent becoming more and more intelligent, maybe improving itself, discovering even better algorithms, and increasing its own intelligence is one. Automating the economy is also something that a lot of people are talking about. How can we bring agents into all aspects of the economy, every company out there automating the work? And then there's this other direction that I'm personally very passionate about, that's personal AI. So this is, for me, this is the idea that each one of us will have a digital entity, this personal agent that accompanies us, that understands us really, really deeply, that can proactively reach out to us, and essentially can improve our lives, can make it happier, can make it go more smoothly. And perhaps this can actually be the next big computing paradigm. Because we've seen lots of developments, the personal computer, the mobile phone, the internet, and perhaps digital entities that understand us deeply and that assist us could be the next big development. We've actually seen some early examples of these personal AI systems, like OpenClaw or Hermes Agent. But if you've played with these, I think you understand that there's not that huge mass market appeal yet. So you have to tinker quite a bit with it. You have to maintain it really well. And there are some big, big problems that haven't been solved yet. Once we do figure out how to solve them, I think this could be a really interesting future to live in, where we don't just have human relationships, but we also have relationships with these digital entities that are optimized to help us, to understand us deeply, to get things done for us. So this is the kind of future that I think I want to live in. But to get there, there are at least 5 problems that haven't been solved yet that are really, really serious. So one problem is you actually want to optimize for the personal AI use case. So you want to run reinforcement learning for personal AI. Today's personal AI systems, they're often coding agents that are generalizing the personal AI use case. So we really want to figure out how to do our training for personal AI. Personalization has to be something that we solve, because if you have an agent that's running 24/7 in the background, that's doing things autonomously, then it better have a really good understanding of how to help you. So that's important. Memory and long context are crucial, because some of these tasks, they could span a whole 24 hours or multiple days. Privacy and security are super, super difficult problems, because today we have things like prompt injection. Imagine like your friend or your enemy texts your personal AI agent a string that then allows them to take it over, and they can get all your secrets. So we have to prevent that. And then lastly, a big one is cost. So if you add up how many tokens do you consume if the agent runs 24/7 in the background, and how much does it cost, you can easily get to thousands of dollars a month. It really becomes prohibitive for most people. So these are the big challenges that we want to solve. There's also an opportunity to change the game when it comes to ownership and control of AI. So currently, with the current paradigm, coding agents and so on, a lot of control sits with the AI companies that provide LLM APIs. And if we kind of go through the development of computing with mainframes, then personal computers became a thing, the smartphone happened, and so on. Now, cloud AI is sort of a step away from giving the individual control. You don't have the physical device, you don't have the means for doing inference, but personal AI potentially could be a way of getting back into that regime where you maybe have a physical device in your home or in your office that contains the model weights, that stores your private data, which is more secure, which is better for privacy. So it's not something that's guaranteed, but it's an opportunity for us to build something that's really for the benefit of the individual. So let me now quickly jump into a few of these research directions. I only have very, very little time, so I can't go into depth here, but how would you tackle something like agent memory, for example? So I believe there are really sort of two different philosophies about how to handle agent memory. One is the idea that memory should be handled in context, so as a memory system that the agent can access, and a lot of the information is transferred via tokens or text. So you might be able to retrieve a phone number, or you might be able to retrieve a past conversation that you've had. And the other philosophy is to actually update the model at the weight level. And I believe each of these have different advantages and disadvantages. At the weight level, it's really hard to store individual facts, like a phone number or somebody's name. And in the in-context world, it's really hard to store that implicit knowledge, like what's the preference, what are the preferences of my user, what's the style in which they're writing their emails, maybe can I imitate that? It's so hard to specify in a text file. So I believe we need both of these. And here are some research papers that go into details that provide approaches for how you could implement memory systems with both philosophies. There's also the direction of personalization. So how do we actually align this model not just with the whole population of users, but with the individual user that it's serving? And like I mentioned, I think this is really important for the agent to reliably represent you and successfully do things for you in the background. And there's sort of two philosophies here about how to personalize. One is more on the passive side, so observe what the user is doing, basically leverage all of the data that they're generating in their life. The other one is more of an active approach, probe the user to understand their preferences, or directly optimize against their feedback. So if I'm telling the agent, this was good, this was not so good, then we want to update the model weights or update the prompt of the system for it to become better and better for you. And there's also a lot of activity in terms of research happening here across these different domains. So a few research papers I've also mentioned, I'm also showing here, so feel free to take a look at these. And another category here is infrastructure, because personal AI might actually require a whole different set of tools and newly deployed infrastructure than what we have today. And so two kind of directions that have emerged around personal AI that I think are really, really interesting and can actually be useful today are on the one side, the approach of multi-tenant LoRa. So previously, when you wanted to train your model, you have to update all the weights of the model, and they're in the trillions of parameters these days. So people have found out that you can add these so-called LoRa adapters, which only represent a small fraction of the weights and only modify those during training. And this opens up a lot of possibilities for how to do post-training and RL more efficiently, and can even open up the possibility of having one custom fine-tuned model per user in the future. You can also experiment with continual learning using these tools. So these are really, really powerful toolboxes. And at River AI, we've also built our own multi-tenant LoRa system, which we've released. And on the other end, we have local hardware. So there's an opportunity there to basically move your inference from the data center to a local device that's either in your hand or maybe in your home or in your office. And today, people are starting to explore this, but there are still a lot of opportunities. There's a lot of low-hanging fruit in terms of how to optimize these local inference systems. And it's possible that a local inference might actually start to rival the data center inference one day. The big bottleneck there is model capacity. How do you fit these trillions and trillions of parameters into a small form factor, and how do you do inference efficiently without overheating your home? Today it requires a whole rack of GPUs to be able to do this, but in the future, we're hoping this might be just a single device. So if you're interested in this kind of new infrastructure, I couldn't resist plugging our own product here. Please check out river.ai/API for our multi-tenant LoRa system that allows you to do research on post-training and RL very effectively, and also allows you to explore continual learning and some of these new ideas that are now coming out of academia. So yeah, and by the way, this whole thing was written by my personal agent because I was pretty lazy today, but yeah, thank you so much.